Good evening, ladies and gentlemen. Hope you all are safe and sound. So first of all, it's my great pleasure to welcome all of you to NanoSpark 2021, organized by the IEEE Industrial Electronics Society Student Branch Chapter of Sri Lanka Technological Campus. So I'm ɪᴅᴜᴜ괜 and I'll be your moderator for today. So today, it's all about nanotechnology. So our main intention is to make undergraduates aware of what is nanotechnology and its impact on the electronic field, which is an open platform for all the undergraduates in Sri Lanka. So in this NanoSpark 2021, there will be two phases. The first phase is a webinar and a panel discussion with the theme of nanotechnology through electronics. The second phase will be an article writing competition. So today, you all are here with a webinar on nanotechnology through electronics. Before moving into the session, I would like to invite our project chairman of NanoSpark 2021, ᴍᴜᴜ to officially welcome the gathering.
Thank you, Agisha. Hope I'm audible enough to everyone.
Yes, ᴍᴜᴜ.
Good evening, special guests, members of IEEE IE Student Branch Chapter of SLCC, members of the organizing committee of NanoSpark 21, and dear participants. I sincerely thank all of you participating in this session. I hope you are staying safe and healthy. Welcome to the introductory webinar on nanotechnology through electronics of NanoSpark 21. On behalf of the IEEE IE Student Branch Chapter and the organizing committee of NanoSpark 21, I extend a delightful welcome to our guest speaker, Dr. Yasun Kannangara, Research Fellow of SLINTech. We are honored with your gracious presence. I cheerfully welcome the members of the organizing committee and all the participants in the session. We are indeed grateful for your presence. The introductory webinar on nanotechnology through electronics will inform everyone about nanotechnology, its uses in the industry, and the future application with the help of the most talented individual present here today. This is the greatest opportunity for the curious nanosparkers to gain more knowledge on the topic of the advance into the future. There will be an interesting Kahoot session, so I invite you all to join with that. I hope everyone will have a good time. Once again, with the great pleasure and the enthusiasm, I warmly welcome you all to the session. Thank you.
Thank you very much, ᴍᴜᴜ. So I would like to remind you of the fact that we are hosting a live Q&A session to answer all of your questions. As you can see, there will be a link in the Zoom chat. If you have any questions or if you have something to clarify, make sure to drop your question in our Q&A platform Slido throughout the webinar. And also there will be a Kahoot session at the end of the day, so stay tuned for that as well. So okay, now without wasting much of the time, let's move on to the most awaited segment of today's session. We have invited a special person to educate you on nanotechnology through electronics. He completed his bachelor's degree from the University of Colombo and master's in nanotechnology from the University of Peradeniya. And he's currently working as a research fellow in the field of energy storage-based material sciences in Sri Lanka Institute of Nanotechnology. He earned his PhD from Sangkyunkwan University, South Korea. His research work has accomplished novel materials for energy storage and provided several distinguished awards, including the Sri Lanka's President's Award for Scientific Publications in 2017 and Superior Research Award in 2019. He is now working in redox active materials and novel two-dimension graphene-based materials, nanocomposites. He is Dr. Yasun Kannangara. So doctor, hope you are having a good time here, and thank you for accepting our invitation. So now the session is all yours.
Okay, thank you, Agisha. Okay, let's go to the presentation. You can see that, right?
Yes, sir, we can see that.
Okay, so good evening, everyone. Today the session is about the nanotechnology with electronics. So on the other way, we call it nano electronics. I'm Dr. Yasun, as Vagisha give me a lengthy description about me. Anyhow, let's get back to the session without any delay. So first of all, the technology, this type of technology will be much more new, but as well as complex. So before I'm going to give kind of brief introduction, let's see about these words, the nanotechnology. So kind of nanotechnology has built on the nanomaterials, but there are no any kind of specific specifications, specific definitions for the nanotechnology. So nanomaterials are typically, we call it in between the materials in between 1 to 100 nanometers. So 1 nanometer always equivalent to the 1 billionth of meter. So for example, we take a kind of a sand. Sand may have macroparticles like stones. So in between those, there will be like a very tiny particles, like little dust particles. So we're talking about those very tiny particles, except the bigger molecules. So the nanomaterials, you may have questions. I will finish the session, then later on you can ask the questions. Is that okay? Someone already raised his hand. Anyhow,
yes, so we have a Q&A session after this your speech. Then we can move on to the questions.
Okay, yeah, sure. So the technology maybe normally are making utilizing the knowledge of the tools, and we're using kind of different techniques. So the nanotechnology means we use kind of a tools and techniques that we want to deal with the materials that the particle size or the diameter in between 1 to 100 nanometers. So usually a material whose size around the 1 to 100 nanometer, at least one of the dimension is normally considered as a nanomaterial. So the different sizes of the material compared with the nanoscale dimension as showing in this picture, we're talking about the yellow color highlighted area. So as you can see, the latest definition is kind of a 1 nanometer to 100 nanometers, but the picture I took from the old journal, maybe they have a different dimension, a different range. So anyhow, this is kind of a material we use in between 1 to 100 nanometers. So the nanotechnology, when we're talking about nanotechnology, the nanomaterial means the material which has in a nanoscopic range, much very important. So maybe I have to stick on that. So it may be a little bit based on the material chemistry. So I hope you guys will aware of it. For the electronic part, this may be not exactly as the same as normal electronic session, discussion about the normal electronics, because you might aware with the resistor, or I will come with the transistor or the condenser, but it's not like that. The nanoelectronics means the materials we use for the nanoscopic materials we use for the electronics. So it quite be different than the normal electronic discussion. So let's get back to the next slide. Before I'm talking about the nanotechnology, let's see who is this guy. This is the Professor Richard Feynman. We call him the father of nanotechnology. He's the person who invented this in 1959. He gave kind of a talk, much more promising, as more famous. His words that he in brackets say there's a plenty of foods at the bottom. So that part will be much more famous. And in 1959, it's something not much impressed by the audience, but somehow at the beginning of the 1980s, when the new technologies come and they could able to see there are little world around that normal material, so they getting more convenient about that, and they got they got to know about that. So then his speech become much more famous. So he's a father of nanotechnology. That's how we mention him. As the size got smaller, one would have redesigned tools because of the relative strength and the various forces would be changed. So at that time, the gravity also much more less important because the in between two materials, the van der Waals forces or the ionic bonds are much stronger. So we're talking about that sort of a nature. So before you try to go down, try to get kind of a clear idea about this. The nanotechnology of nanomaterials, which have kind of a different nature rather than normal materials. So Richard Feynman once mentioned these upscaling issues during his talk, because at that time, the 1959, maybe there are very basically developed scanning electron microscope or different kind of tools were there, so they don't have much techniques to look inside of the nanoscopic range, but his words, I mean, his point will be like more promising. So before that, let's go back to the normal talk about the nanomaterials. Just for the brief understanding, you can easily get to know the nanoscale, the materials which normally rely on the nanoscale or nanodimension. So nanodimensions mean in between 1 nanometer to 100 nanometers. So in here, just showing kind of a different atoms or the molecules, but mostly that graphene, gold nanospheres, and as well as a multi-walled carbon nanotubes will be. I mean, there will be more applications. I will explain at my next slides. So you can easily ask me a question: why nanomaterials? What about the macromaterials? What about the more than go beyond the nano or the pico range? Means we are talking about 10 to the power minus 9, but how about 10 to the power minus 10? I mean, it's pico range. At that level, it's maybe the atomic level. So in the world now, there are no any kind of a technology to handle such a smaller nature. So the nano range is the range that we could easily handle and the control and all their chemical reactions and the physical or the chemical behavior. So that's why the nanomaterials will be very famous. So normally they are much larger. So they might have different natures like quantum effects or ultra high surface area or something like that. So because of that, their reactive nature will be much more changed. So it is important to note that the nanomaterials have different properties than the same material at the macro level. So the material have a high surface area. I will explain the factors. What are these things at my next slide, and the surface area as well as the size scale where the quantum effects can rule the behavior. So in the nanoscopic range, the quantum effect can exactly rule. It's kind of a different phenomena or the fascinating kind of mechanism that you can easily see the quantum effect. When we're talking about the nanoscale, there will be a kind of tunability property. That means the material which showing a different kind of a colors or material that showing a different kind of behavior in a chemical nature or the physical bodies. So that we mention as a quantum effect. For example, in this picture, you can easily see the macro. I mean, like a larger particles of gold, you can easily hold on your hand. It's tangible. But in a nano gold, in the different sizes, it's going to give a kind of a rainbow colors. I mean, with the different particle sizes, it's give a different shapes, or sorry, different colors. That means the color comes from the structural colors. It's kind of deviate from the normal light and emit. I mean, it's absorbing the normal light and emit kind of different wavelength. Only the specific wavelength. So that's what we mentioned here in the nano confinement effect. So, for example, just think the macro particle is here, kind of very small amount of surface. When the particle is getting more and more smaller, the surface area getting more. For example, just think the particles like as a powder, so the surface area getting more 100 or 200 times or 200,000 times, much higher. So for this is the cube, and this is also the same amount of materials, but when the particle size getting more smaller, their reactive nature is getting much higher. How it's happened? So because of the high surface area, the more materials can expose to the surrounding environment, which can greatly shape chemical reactions of these materials or the reactivity. One benefit is the greater surface area and improved reactivity. In nanostructured material, they have the help to create the better catalyst. Because of this nature, they use mostly the nano catalyst. I mean, normal catalyst can stimulate the reaction, but the nano catalyst much more, 10 times or the 100 times efficient than the normal macro level catalyst. Let's go to the quantum confinement effect. So the can be observed once in a diameter of the particle are changing in the certain nanoscopic range. For example, this is lowered unoccupied molecular orbital and the highest occupied molecular orbital. So the one, actually here the quantum dots, I'm sorry about that, I have to mention that. So let's talk about quantum dots, kind of particle that in the nanoscopic range, and when the quantum confinement effect alter the energy in between the band gaps. These are the two bands, energy bands. So in between that, the electrons will be going back and absorbing the energy and getting more excited and going to the upper level again. Anyhow, it's coming back to the normal state, the HOMO level, I mean highest occupied molecular orbital. Then at that time, they emit the energy. So this energy may be in a visible range. So you could easily able to see the color. So directly this energy absorption of the emission is directly related into optical and electrical properties. Because of that, we could able to see kind of a colors. So the different energies, I mean, showing a different colors. So before that, we need to mention that these are the materials, but how we able to screen this thing? There are a lot of technologies. Mainly, I try to focus about these three characteristic techniques. Maybe because other techniques much more complicated and the time frame will be not enough to explain everything. So somehow for the undergrad student, these three techniques may be much important. So these are the scanning electron microscope and atomic force microscope. What happened in the scanning electron microscope? They use kind of different magnetic lenses, and there are no any light rays. They have the electric energy beam. This will be the simple schematic picture, but exactly with the practical nature, the real SEM or the scanning electron microscope machine, it's too complicated, not exactly like this, but this is kind of general image for better understanding. So using the electron beams, you can easily put into the surface with very tiny atomic range. So that's why the you could able to see the pictures very clearly. I will get back to the SEM, but before that, let's go back to this picture. This is atomic force microscope. So there are a few interactions in between the surface and the tip. So this cantilever can be movable. So when the laser hits and reflect into the photodetector or the photodiode, when the tip is moving from here to here, the atomic force in between the tip and the sample will be changed. So according to that, the tip is getting moved. There are a few techniques like a contact mode. Contact mode means tip and the sample will be contact each other. Non-contact mode, that means the both tip and sample won't contact, but because of the magnetic nature, they're moving parallelly. There are a lot of technologies like that, but the AFM and the SCM will be more complementary. The researchers and the process control facilities are increasing seeking instrumentation to visualize the surface feature to make special measurements of the nanoscale. So using the electron beams, that this microscope technique and the scanning probe microscope technique also much more famous, but using the atomic force microscope as well as the scanning electron microscope, there are some advantages as well as disadvantages, but rather than other techniques, these two will be much more easier to understand as well as easier to utilize. It's something that this SEM image or the scanning electron image, I'm saying, they have kind of fantastic field of depth. That means you could see, I will explain that the term at the next slide. But the AFM has a poor depth of field, but the providing amazing contrast of the flat surface. So the scanning electron microscope has a high depth of field, but comparable to the AFM or the atomic force microscope, it has a lower contrast. But AFM has high contrast, but kind of lower depth of field. This is the nanoparticles or the structures that we could able to see at the normal nature. The top of this picture, these are the collection of pollens. This is the nanoscopic range. I could, I'm sorry about not to put the scale here, but anyhow, these particles will be around 10 or 20 nanometers. These are the different pollens collected from the tree. And, you could able to see the human hair, the SEM image of the human hair that may be much bigger than normal. Normally what we see. And this is the tunneling electron microscope image that took using the COVID-19 virus, were freezed and dried, and then they able to put it into the machine and get these images. And colored means that there are software. Actually, the original image will be black and white, but using the software, they can color the image. So after that, you could able to see these kind of pictures in the structures very distinguishedly separated. And this is the insect eye. They have the complex eyeball. So the inside the eye also there are little tiny eye particles. So these are the structures that how it's going. So in the real nature, the nanotechnology, nanoparticles or the nano nature will be much prominent as well as very diverse. So that's the natural, but here even human beings can synthesize the nanoparticles. So we're talking about the graphene. So these are the graphene nanoplate. And zirconia disk, actually, those are the pentagonal shape or the pentagonal shape disks. Actually, these are the nano disks. These are 2D materials. It's like a book that with a huge number of pages. So in between these two layers, that maybe other particles, so different kind of foreign atoms can impregnate or the embedded. So there are different applications of that. And the pentagonal shape, the zinc nanocrystals. And have you ever seen the salts that we use in day-to-day life? This is the salt cube. So it's totally like a cubic shape. And the nanosilica sphericals. Normally that sand, we have to clean it with the mesh, and the smaller and much more smaller particles are getting like this. So there will be a different type of technologies, techniques for synthesizing this. I'm not going to explain those things one by one because of that. It may be like a more chemistry lesson rather than the nanotechnology session. But talking about the electronics, this technique will be much important. So the nanolithography is kind of technique. It's something like an art. We make a nanostructures using different materials, but the structures are maybe highly complex. As you see, this is kind of a circuit for using a sensors. So we put our material actually in here, in between these, connecting these two wires. The mechanism or the design is done by the nanolithographical. So in here also the silicon, nanotube forest at the silicon surface, as well as the complex lenses array for kind of optical different laser panel. All are fabricated by the nanolithography. So nanolithography will be like a technique or the art. You are sculpturing that different sort of nanostructured material, like a pattern that that those devices can easily use that structure or the array or the pattern to their as a active component. The nanoelectronics. So you can easily understand, okay, the nanoelectronics is the electronics that they use for the nanomaterials. So maybe that's why I said that electronics, you know that normally we talking about the resistivity or the using the resistors, conductivity, voltage, current, and resistivity. Those are the three major elements that using different sort of techniques use major three elements or major three components in electronics: resistor, a transistor, or the condenser. So these are the three equipments or three tools that we majorly use in electronics, and vice versa. We just mix it and talking about how the electronics works. But when it comes to the nanotechnology, it's not like that. So resistivity or the condensers or the conductivity using the different parameters are not reliable. Here we are talking about different sort of nanomaterials which embedded into the system or the device, and it's given kind of a new electronic component. So we couldn't able to say that this is the resistor or this is a transistor or this is a condenser or something, or the capacitor or something. So it's behave like a different whole unit. So, but when we're talking about the nanoelectronics, there are common characteristics that they are much smaller, and the atomic interactions are there, and the quantum mechanical properties are there, and some of these candidates, something like semiconductor devices or the one-dimensional nanotubes or the nanowires will be there. So they are showing kind of advanced molecular electronics. In here, this optical image is about the graphene wireless sensor that printed on the tooth. I just want to put here that because I just want to give you a clear idea that how much smaller we can print using the nano lithography. And here the breadth means the inside this device there will be a little small of pattern printed by the graphene, and this will be acts like a sensor. And in here, the Sri Lanka Nanotechnology Institute, there are a brilliant scientific group with a bunch of scientists. They produce this mask and the sensor to measure the breathing rate, carbon dioxide, the buildup, or the how the breathe in and breathe out, exhale and inhale, the pulmonary volume goes on. So it may be a good indicator for your health. There somehow there will be a much more options that anyone can mention, but here I majorly rely on these materials, or sorry, these applications that can easily explain, and you even you could be able to understand it much more easier. So when we're talking about the wearable electronics, normally we see the OLED or the LED is kind of tangible, that little tiny particle, tiny bulb that we could use in our fingers. But now the real nature is kind of different. So the bulb is not like that. It's kind of a little thread, little kind of a wire that emits the light. So how these technologies can be done? I mean, it may be very flexible. So that's why the nano materials come. So the nano materials, we have to embed it, something like a ion transition metal complexes that using luminescent nanofibers. And they both together co-electrospiny. Electrospiny means they secrete that particles or that material like a little tiny thread through the like a little device. For example, just think injection tip. So we just press it, and other side the liquid or the whatever the thing comes like a stream. At the same way, we can easily secrete or make the electrospinning technologies and giving kind of a different voltage. While the voltage comes, the material will be cured, or the radiation adjusting a UV or the heat, the material will be cured, and it will be come through the injection tip like a little wire. So in here, these are that little tiny thread with the different voltages. At the 6.8 volt, it give the light as much more bright. So this is kind of using this thread, we can easily make kind of textile or the flexible wearable electronic. So it may be light emitted, and there will be many applications in the future. Everyone knows, I mean, there will be famous in Sri Lanka. We couldn't able to see, but at the future, there will be a very famous battery component, Samsung graphene board battery. Still under developing, and they will provide it at the very near future, I guess. So inside the material, normally the lithium-ion battery material, that normal lithium compounds are there, but they use graphene and covered it as a ball. So that's why the people call it as a graphene ball. I'm not going to explain further much more informations were there. Maybe harder for you to understand it. So somehow, sorry. Okay. So somehow, when the graphene comes, the surface charging or the discharging rate will be increased. So the improving one property without sacrificing the other properties, something like that. When we adding a graphene, the charging rate will be high, but discharging rate also getting much higher. So that will be a disadvantage. So when we going to increase the power, sometimes the battery's energy will be getting dropped. So likewise, it's too harder to develop, but improving one property without sacrificing the others, that will be challenged. But this group, actually the Samsung graphene ball means that Samsung, the scientist group from the Samsung Electronics did this. So they use kind of a silica and the graphene embedded ball, and they call it as a graphene ball. So they covered it with the lithium-based compounds. So NCM compound is there, means the nickel, cobalt, manganese-based oxides were there, and covered with the graphene. So 1% of graphene were added. Because of this coating will be a nano coating, but somehow this graphene ball improve that it's give kind of supercapacitive property, that highly charged, but when it's releasing the energy, it's getting much more slower, or very like a hold in the electrons without giving it as much as easier it's taken. That means the capacitance is very much ultra high than normal conventional battery. So this technique will be very famous, and then I guess now the Apple and other groups also using. I could able to put the graphene battery from the Apple Electronics at USA. That's the energy storage technology. So let's talking about the energy harvest or energy generate. So this is the perovskite cells. Normally, the solar cells has a photonic crystals. Crystals means it's a different photons. Photons comes from the solar rays that absorbing and converting into the electrical energy. So here we all know that the perovskite means that's the photonic crystal we use, but in here there will be a PN junction also. So the perovskite and the electrolyte copper will be work, and given the photons converting into the electrons. So this technology, we use nanolithography. Actually, the lithography has a different technologies. So lithography means a kind of big word, but we can divide it into the many things. I mean, electron beam lithography, imprint lithography, dropping tip lithography or something. There are many applications we can divide it. So this solar cell, we use imprint lithography, which allows to create the optimum surface texture on the large areas. For the thin film cells, the texture is optimized for light trapping. So light trapping is an important concept that allows to minimize the material consumption and absorbing the layer much more photons from the light. So the combination of the front side texture in here I'm showing, which deflect the more photons into the cell, and it's something like a wall that a photon will be dropped into that, but it's never let it to go there, because the here there will be photons comes and easily absorbing by the nanoscopic range and not let it to reflect back. So likewise, this solar cells will be absorbing much more high photon stream, and the efficiency of the producing current will be high. So let's get back to the perovskite with the energy harvesting application. So energy harvesting means the two surfaces will be like a clapping. When we clapping with the two surfaces, that current will be developed. So we call it like a triboelectric nanogenerators. So using these two technologies, I mean, we could able to make a sustainable wearable device. In the downstairs, that the person who wearing kind of t-shirt and the devices, that this person will be like he's in the running or the jogging, or his body will be in the movement. So at the moving, the two surfaces will be touching each other and producing kind of or the harvesting kind of a current. So that current may be not much bigger, but it will be like a nanoampere range current, not like a microampere or the ampere. So the nanoamperes can power very smaller device, like a Internet of Things we explained, that much smaller sensors like device that only scavenging nanoampere range current. So using these type of devices, the flexible surface devices that embedded into the fabric, we can have those devices, and it clearly contains your heart rate sensors. Now also there are many research going on like these type of devices. So they what happens normally when the heartbeat goes on very abnormal, that this device will be send a kind of a message to the mobile phone or someone else, or for the caretaker, or the person maybe have a cardiac arrest or something. So likewise, maybe much more easier and more convenient and more healthy and friendly, health friendly for the person who wearing this. As well as there are many 3D printed devices. I mentioned that research improved these devices for detecting the capabilities that electromagnetically active soft functional materials combine like gold or aluminum and different type of soft materials like polymer, not nylon, but some sort of a soft type of nylon and a soft type of polyethylene compounds. So these type of devices can monitor the pH, and maybe this type of devices can monitor the pulse rate inside on your wrist. So the pH means normally at the high blood acidity, maybe when you have like a high blood sugar, so the acidity will be goes down, then the pH getting dropped. So at that time, the sensor will be give the kind of a indicator. Okay, your sugar level will be goes down or goes much more higher or something like that. So these type of techniques that using. So the current wearable sensors are facing various limitations because the smartwatches, for example, need to be charged, and they can only gather the limited amount of data, only around your wrist or something like that. So by using a 3D kind of a 3D scanned devices, something like this, like little net, we can wear on our hand or something, or wrapping any kind of places that on our body that can easily gather the data, the pH, sweat pH, or sweat glucose level, body temperature, or the humidity, or how the pulse rate goes on. There will be much more indicators that regarding the health of the whole. So that's the presentation, and I'm sorry that the presentation goes on the like material characterization, but because of I'm not go through that, maybe much more lengthy, harder to understand when getting based on the chemistry. So that's why I try to explain the applications and the technology. I hope you guys understand that in much more clearance. And if there's any kind of question now, I think it's time for.
Yes, thank you very much, Doctor. It was a very informative session. I believe it's an amazing start as well for NanoSpark 2021 itself. So while it was a great session, I'm pretty sure the audience have some question to ask from our guest. In that case, let's move on to our Q&A session. I would like to remind you the fact that there will be a link in the Zoom chat. If you have any questions, feel free to drop your question there. But if someone has submitted the same question, please vote for that question without typing the same question again. So it will come up to the top. So let's take a look at the questions we have received so far. So the first question is, are there any specific health or other risks from nano products?
Yeah, normally the nano materials, inside, just think our skin. Skin has a micro range pores. So when we are dealing with the nanomaterials, we have covered everywhere. I mean, so some particles or the nanoparticles will be health friendly. For example, silicon dioxide nanoparticles, something. But some particles are not. Even though whether they are friendly or not, they might be go through our nanopores inside the skin. So it may be affect with much allergies, the skin irritations or something. So yeah. The question is yes. Answer is yes. There will be a kind of a complication.
Okay, thank you, sir. So the second question is, if someone wants to buy nanotechnology products, where can we purchase them?
Actually, in Sri Lanka, there are no such a place. I mean, nanotechnology, every industrial people were like impressing about it. So we couldn't able to say this guy will be sell only or that guy will be sell only. There will be many people or many companies or selling those nanotechnology based products.
Thank you, sir. So the next question is, can nanotechnology help to protect the environment, or is it harmful for the environment?
It's depend on how we apply. For example, let's talk about the fertilizers. In Sri Lanka, this Sri Lanka Institute of Nanotechnology made a kind of a nano fertilizer that very slowly release the nitrogen to the soil. So that maybe protect the fertilizer itself as well as the soil. Because just think we put different type of fertilizer, it will dissolve to the water and washed away until it go back to the sea. So even the plant doesn't have any time to absorb it. It just very rapidly dissolve, and with the rain, water goes through the streams and go to the sea. So in that case, it might be need to release very slowly. So the slow release fertilizer makes more eco-friendly as well as protect the plants as well as the soil. So
Okay.
On the other hand, we can use different materials for giving a hazardous environment. So the same way, the way that we applied may be dependent on that.
Thank you, sir. The next question is, what's the demand for nanotechnology in terms of job opportunities in Sri Lanka?
In Sri Lanka, actually I have to say this, technology-wise, Sri Lanka is not that much developed. So maybe the new technology comes, it may be famous and we all are like to have that, but in the job market, maybe if you are working like a scientist level, you can come and join with the Slintech or something, or even universities, some of the universities doing nanotechnology based research. Some companies actually, they are now purchasing or the manufacturing nanotechnology based products. But I have to say that we are still under developing. But at the future, there will be much more opportunities, but currently it will be like a very low amount of applications or the opportunities.
Yes, thank you. So the next question we have received is, what are the ongoing projects in nanotechnology that you do in Slintech?
Now I'm working as a battery scientist, so I'm working with CodeGen, Vega people that about their battery project, and there will be another few clients will become. So briefly saying, the flow batteries, lithium-ion based batteries, and the graphene-based energy storages like supercapacitors or other sensor materials will be those are the research what I'm doing.
Okay. So the next question is, what are the most popular companies in the world that we can join after completing the degrees in nanotechnology?
After finishing your master's, right?
Yeah, after completing the degrees.
Degrees means the bachelor's or the master's?
They haven't specified in here.
Okay. For example, you finish your bachelor's, so then you can go for a higher studies with those foreign universities or in the Sri Lankan universities as well. Or if you're finishing your master's, then you can go for a PhD. That's for the advice. Let's talk about as employment that some companies in Japan, they use different companies that have used activated carbon. So Sri Lanka producing the coconut shells, burning and producing much high amount of activated carbon. So the Japan companies absorbing that. So even though some people also have opportunities to go there and work. And but the salary wise, I'm saying that America has paying much more, as well as they have a larger number of industries. So, for example, silicon-based materials in Intel, or the lithium-based materials in Tesla, that the two most famous companies. But other than that, there will be a larger number of companies, but you need to sharp your skills at the tip point until otherwise will be harder to absorb any of it.
Okay, thank you, Doctor. So that brings us to the end of our Q&A session due to some time constraints. So I have to say, Doctor, honestly, it was an amazing session. Definitely the best start we could have got to start off NanoSpark 2021 itself. So thank you very much, Doctor, for joining us today, even though you are a very busy person. And we would like to appreciate you from our side for the support and the commitment you gave in making today's event a success. So the organizing committee of NanoSpark 2021 would like to issue you a virtual token of appreciation. So I kindly invite you to accept this.
Okay. Thank you very much.
Thank you very much, Doctor. And now let's move on to another fun session. It's time to the Kahoot. So quickly grab your mobile phones and head on to kahoot.it, just in case we have provided the link in the Zoom chat as well. And then use the pin given in the Zoom chat as well. So the technical team, can you put the Kahoot pin in the Zoom chat box? Everyone, please make sure you get your mobile phones and head on to kahoot.it. And here we have the pin. The game pin is 2353127. 2353127. And we'll give you 2 minutes to come onto the game. And just a small reminder, you will have 15 questions to answer. And if you want to score high marks in this game, you have to be both correct and fast as well. Come on, guys, join, please. Okay, so we have Shi here, Hoshan, Biraj, Nisala, Didula, Vimukti. Come on, everyone, we'll give you 2 minutes. And a small reminder, please try to use your first name as the username of this game. So it will be easier us to identify you. Okay, we have 36 people with us. Come on, everyone. Others, please join. We'll give you 1 more minute to join with us. So far, we have 42 people in the game. Everyone, please join. The game pin is 2353127, and try to use your first name as the username. We have 50 people on board, and please others join as soon as possible. We'll give you 30 seconds. So far, we have 54 people on board, and we'll give you 15 seconds to join us. Okay, so we have 55 people. Let's start the game right now. Okay, so the first question is nanoscience is the study of what? Phenomena on the scale of 1 to 100 nanometers, phenomena on the scale of electrons, phenomena on the scale of single atoms, phenomena on the scale of 1 to 100 millimeters. Make sure to give the correct answer. And also, okay, we have 39 correct answers. And let's move on to the, okay, so we have the podium. As you can see, the first place goes to Thua, and the second place goes to Asanka, and the third place goes to Ditula Vimukti. Okay, let's move on to the next question. Okay, so the next question is prefix nano comes from a French word meaning billion, a Spanish word meaning particle, a Greek word meaning dwarf, a Latin word meaning invisible. Make sure to give the correct answer as soon as possible if you want to be in the top of the leaderboard. Okay, so we have 24 correct answers. Let's look at the leaderboard. Okay, we have some changes in the leaderboard. Still Tua at the top of the leaderboard, and second Asanka, and third we have Hoshan. Let's move on to the next question. Who first used the term nanotechnology and when? Richard Feynman in 1959, Morio Taniguchi in 1974, Eric Drexler in 1986, Sumio Iijima in 1991. Okay, so we have 13 correct answers. Let's look at the leaderboard. Okay, still Dua is at the top of the leaderboard, and then we have Asanka, and then we have Hoshan. Okay, let's move on to the next question. The scanning tunneling microscope, SEM, capable of imaging the nanoscale, was invented in Germany, United States of America, Japan, and last one is Switzerland. Give your answer as quickly as possible if you want to be the top of the leaderboard. Okay, that was a tricky question because we have only 11 correct answers. Let's look at the leaderboard. Okay, so Hasanka has on the top of the leaderboard. Then we have Tua, we have Hoshan at the third place. Okay, let's move on to the next question. The first US president to have his image rendered at the nanoscale is George W. Bush, William Clinton, Barack Obama, and Ronald Reagan. Okay, so we have 19 correct answers, and let's look at the leaderboard. Okay, still we have Asanka at the top of the leaderboard, and we have Tua, Hoshan, Sitira, and Oluka respectively. Let's move on to the next question. How many oxygen atoms lined up in a row would fit in a 1 nanometer space? Make sure to give the correct answer as soon as possible if you want to be in the top of the leaderboard. Okay, we have 16 correct answers. Okay, we have Still, Asanka remains at the top of the leaderboard, and then we have Tua, Hoshan, Sitra, and Yatu respectively. Let's move on to the next question. Seventh question is, which of the following has been created by scientists in nanotech laboratories? A nanoscale box with a lid made of synthetic DNA, a paper battery that you can fold or cut, carbon sheets, one atom think, all of the above. Okay, that was a pretty easy question. We have 36 correct answers. Still, we have Asanka, Tua, Hoshan, Sitira, Yatu on the leaderboard, on the top of the leaderboard. So let's move on to the next question. Which of the following are nanoscale? West Nile virus, red blood cells, white blood cells, human hair. You have 10 seconds to answer. So far, we have more than 40 answers. Okay, so we have 16 correct answers. Let's take a look at the leaderboard. Okay, there has been a slight change in the leaderboard. Tua has come to the top of the leaderboard. We have then Hoshan, Asanka, Sitira, and Yatu respectively. Let's move on to the next question. The ninth question is, the width of the carbon nanotube is 1 nanometer, 1.55 nanometers, 1.3 nanometers, 2 nanometers. Make sure to give the correct answer as soon as possible. Okay, so we have 13 correct answers. And the leaderboard remains the same, Tua at the top of the leaderboard. Okay, so the 10th question is, optical tweezers are used to remove facial hair with miniatured laser beams. Use light to manipulate particles as small as single atom. Are a nanotechnology-based tool for stamp collections, or none of the above? We have 15 correct answers for that question. You have 5 questions remaining, and Hoshan has come to the top of the leaderboard. The next question is, which of these historical works of art contains nanotechnology? Come on, everyone, give your answers as soon as possible. Make sure it's the correct answer. You have 10 seconds. That was a pretty easy question. So we have 24 correct answers. And we have a change in the leaderboard. Still Hoshan at the top of the leaderboard. And then we have Tua, Asanka, Sitira, and HM9 respectively. Let's move on to the next question. So the 12th question is, the world's largest carbon nanotube manufacturing facility is in which country? A, China, Germany, the United States of America, Japan. You have 10 seconds to answer. Okay, so we have 16 correct answers, and let's take a look at the leaderboard. and the leaderboard remains the same. Yes, and let's move on. So you only have 3 questions remaining. Try to answer as fast as possible. Make sure it's the correct answer. And which one of these condiments is unique due to the nanoscale interactions between its ingredients? Ketchup, mustard, mayonnaise, all of the above. You have 10 seconds. So far, we have got 50 answers. Yes, that's a tricky question. We have only 13 correct answers. Next, let's look at the leaderboard. So Hoshan has come to the top of the leaderboard, and we have Tua at the second, Asanka in third, fourth, Sithira, HM9 at the fifth. So let's move on to the next question. You only have 2 questions remaining. So the 14th question: who is the father of nanotechnology? That's quite easy question actually. So try to give your answers as fast as possible and make sure it's the correct answer. Yes, we have 44 answers, correct answers, and let's take a look at the leaderboard. We have a slight change in the leaderboard. HM9 has come to the 4th place, and Sithira has gone down to the 5th place, and Hoshan is still at the top of the leaderboard. So the last question for today's Kahoot is: in this 1986 book, K. Eric Drexler helped popularize the promise of nanotechnology. Radical Abundance, The Diamond Age, Too Small for School, Engine of Creation. Come on guys, hurry up. This is the last question you will get in this game. So try to answer it correctly. Okay, so we have 14 correct answers. So here's the final result of today's Kahoot. So 3rd place goes to HM9, and the 2nd place goes to Hoshan, and the 1st place is Tua. So congratulations everyone. And yes, that's all for today's Kahoot session, and thank you everyone who joined us with the Kahoot session. And yes, thank you everyone who joined us with the Kahoot session, and I hope you all pumped up with that. And also congratulations to all the winners as well. So that brings us to the end of today's session, and moving on to the conclusion of this. And I would like to invite the project secretary of NanoSpark 2021, Thanuli Devanura, to deliver the vote of thanks.
Thank you, Agnisha. Am I audible?
Yes, Thanuli, you're audible.
Thank you. Good evening, special guests, members of the organizing committee, and my dear participants. I'm Thanuli Devanura, the secretary of the project NanoSpark 21. First of all, I would like to thank all of you for being here, even virtually, amidst the current situation of the country, and I hope everyone is staying safe and healthy, strictly following the health guidelines. On behalf of the IEEE IES Student Branch of Sri Lanka Technological Campus and the organizing committee, I would like to extend my sincere gratitude and thank our resource person, Dr. Yasun Kannangara, a postdoctoral research fellow at Sri Lanka Institute of Nanotechnology, for being here and embracing this event with your incredible knowledge. Thank you so much, sir, once again. I would also like to thank the members of the organizing committee and all the participants for being here. We are indeed grateful for your presence. Our next upcoming session will be the panel discussion, which will be based on the topic nanotechnology through electronics. And I kindly request and invite all the participants to participate for that session as well, leaving no requests. Once again, with great pleasure and enthusiasm, I would like to extend my sincere gratitude and thank all of you again for your presence. And with that, I would like to end my speech. Thank you all for listening.
Thank you very much, Tanuli. And that brings us to the end of today's session. And before the conclusion, as Tanuli said, there will be a panel discussion on nanotechnology through electronics on 16th October 2021. It means day after tomorrow. So I kindly invite you all to join that as well. And I assure you it will be a very informative session as well. So I hope today's session was useful to all of you, and we believe you have got something out of it. Having said that, it's time to conclude this session. Thank you once again for joining us, and see you all in the upcoming panel discussion as well. Until then, have a good day. Good night.